So we are organizing this public workshop where we want to present the Palantir project results after most of the integration had been done. And we will focus today primarily on Pilot 2, which targets small, but more importantly, technology for micro enterprises. I will first give the floor to the CEO of Sfera, Renato.
Yes. Hi, everybody. Due to majority of the Slovenian audience, I will carry on at least this first introduction part in two languages. So let me just first start in Slovene. Lep pozdrav vsem skupaj. Moje ime je Renato Pulko, jaz sem soustanovitelj in direktor podjetja Sfera IT. Tisti, ki nas poznate, že približno veste, s čim se ukvarjamo. Za ostale pa naj samo še na hitro povzamem. Sfera IT je eden vodilnih slovenskih integratorjev sistemskih rešitev na področju varnosti na spletu. Smo tudi avtor slovenskega kibernetskega asistenčnega centra AIS. Kot sama beseda integrator pove sama po sebi, smo se do sedaj ukvarjali večinoma z integracijo, vpeljavo ter prilagoditev obstoječih rešitev, torej strojne licenčne programske opreme, ki v jedru ni bila razvita od naše strani. Palantir projekt pa je naš prvi primer lastnega razvoja enega dela varnostnega sistema, od sistemskih ter uporabniških zahtev do same izvedbe, testiranja in kot bo danes tudi prikazano v demonstraciji tudi v realnem okolju. Več o projektu bom v nadaljevanju povedal kolega Isidor. Naj pa tukaj poudarim, da je poglavitna prednost celotnega varnostnega sistema projekta Palantir prav v tem, da je zasnovan ter krojen po potrebi malih ter mikropodjetij. Tako stališča enostavnosti kot predvidene cene, ki jo naj bi ti uporabniki plačali. V načrtovanju sistema smo ustvarjalci imeli v mislih preprost varnostni sistem na konceptu security as a service, ki bi si ga vsa mala in mikropodjetja lahko tudi privoščila, kajti podatki s terena so alarmantni, večinoma slovenskih kot tudi evropskih malih in mikropodjetij, praktično je nezaščitenih, ali pa je ta zaščita zanemarljiva v primerjavi z vsakodnevno nevarnostjo, katerim so tudi podjetja izpostavljena na spletu. Projektu Palantir smo se aktivno pridružili že v fazi same priprave oziroma prijave v letu 2019. Na njem smo začeli delati z 1. septembrom 2020. Tudi smo v zaključni demonstracijski fazi. Projekt pa se je zaključil z zadnjim avgustom letos. Gre za projekt, ki je sofinanciran s strani Evropske komisije znotraj okvirnega programa Horizont 2020. Jaz še samo prosim, da lahko ta uvod ponovim v angleščini za vse ostale. Hi everyone, everybody that are here and that are joined us online. My name is Renato Pulko and I'm the co-founder and CEO of the Sfera IT. Those of you that already know us, but for the rest of you, let me just give you a quick summary. Sfera IT is one of the leading Slovenian integrators of system solutions in the field of online security. We are also the author of the Slovenian Cyber Assistance Center called AIS. The word integrator itself suggests until now we have been dealing with the integration, introduction and adaptation of existing solutions like hardware and licensed software, which in the core was not developed by us. So the Palantir project is our first example of the development of one part of the security system, from system and user requirements to the implementation, testing, and as it will be shown today, demonstrations in real environment. My colleague Isidor will also explain more about the project in the following, but let me emphasize here that the main advantage of the entire security system of the Palantir project is precisely that it's designed and tailored to the needs of small and micro companies, both of the point of view of simplicity and the affordable price that these users are supposed to pay. When designing the system, the creators had in mind a simple security system based on the security as a service principle that all small and micro companies can afford to use. Because the data from the field is really alarming. Most Slovenian and as well as European small and micro companies are particularly unprotected. The protection is negligible compared to the daily threats the companies are exposed online. We actively joined the Palantir project in the application phase itself in 2019 and started working on September 1st, 2020. We are currently in the final demonstration phase, and the project ends in the end of August this year. It's a project co-financed by the European Commission within the framework program Horizon 2020. So I will not waste you any of my time, so I will hand over the floor to Oleg Isidor.
Yeah, thank you, Renato. So the rest of the presentation will be in English. We don't want to repeat everything in Slovenian because it's the mixed audience. So Palantir is, in a nutshell, it's, as Renato mentioned, it's supposed to be a holistic solution tailored to that can tailor its technologies or its services to the needs of the user. It consists of a portal, which is an entry point for each user. Then it includes threat intelligence that collects network traffic, analyze reports, threats, suggest remediations. Then we have a security orchestrator that facilitates the security as a service model. We have risk-based analysis. This is called for us RAF framework, which actually enables us to somehow investigate and analyze the priorities of specific company and suggests different Palantir services to protect them. And we have also trust and attestation engine, which actually verifies integrity of Palantir infrastructure and services. So this is the high-level architecture. I will not go into too much detail of this architecture because it's quite technical. But in the end, as I said, the main window for both Palantir operators, these are, let's say, Palantir experts that can help our customers to operate the system in some essence and to configure the system. And for the end users themselves, as owners, more or less, it's Palantir portal. So it consists of a dashboard, capability matching and SLA services. It consists of threat sharing and the dashboard itself. The threat sharing is really a novelty in this field because it enables us to understand the field better. So when the attack occurs, we can share this information among other SMEs, to propose additional security measures, to deliver better services more aligned with the evolvement of the threat. So Palantir is actually not a static system. So on the middle layer, we have threat intelligence, which includes multimodally trained machine models, recommendation and remediation engine. We have the orchestrator, the trust and attestation and recovery framework, and risk analysis framework. Everything in Palantir, as you see, can be offered in form of security as a service. And the services are actually fully distributed, as you will also see in the later topologies presented for this demonstration. Palantir builds on, as we said, on risk assessment, virtualization, multimodal machine learning, remote attestation, and creates a highly dynamic and flexible cybersecurity services that can run on a completely secure and attested network environment in the form of security of a service. So it's very important to understand, again, we are not static. How we develop the idea and deploy the idea of Palantir is to be able to respond also to most recent threats and adapt the services, not wait 1, 2, 3, 4, 5 months for a security solution to actually deal with the threat, which is a passive threat, but to almost be to offer a zero-day response to the threats that occur. So in terms of connecting with different components of traditional security systems, we offer services to replicate intrusion detection systems, CMs, security information and management tools, vulnerability scanners, malware analysis tools, forensic tools, threat intelligence platforms, and incidents response platforms. So virtually whatever today you have to buy as a separate component, Palantir can integrate in a single cost-efficient solution. We offer actually different deployment modes. So we do offer in-premises deployment, the traditional way to deploy security services, where everything is installed or deployed on the network and the devices of the client. Usually, this is very much interesting for network operators. But for small and medium companies, this is not affordable. That's why we offer two solutions depending on the level of protection or threats they need. So light CPaaS, this means we call it Palantir in a box. So basically everything runs in a box as a device placed in the environment, and cloud CPaaS. So basically it runs some probes and some services are installed as clients in the environment, but the rest of the platform runs on the edge as close to the premises as possible, and this enables us to get better services, and cost efficiency as well, since we can use a small edge cloud and deploy as Sphera as an integrator or let's say offering these services to our customers. It means that we can run multiple clients or multiple instances at the same server, so it's very cost efficient as well. So today we'll focus basically on use case 2 or pilot 2, which is specifically focused on holistic cybersecurity solution for micro enterprises. So what does Palantir offer for SMEs, but especially micro enterprises that might be better and different than similar solutions in the field or in the market? Basically, we offer a holistic solution with risk assessment framework, where instead of traditional way of talking with customers, we provide some objective means to identify threats, optimize security services, and represent them to the owners. Because this is the key problem, is to make the owners aware that there is a threat and it needs to be solved, and do it objectively, not from, in their eyes, not from the perspective of trying to sell them something, but actually trying to sell them something they need. Then we have this trust and attestation framework. So it offers a cost-efficient and personalized security solutions as a service with periodic integrity verification. So this answers the second question of an owner. Okay, I buy this. How much will it cost me, for you to monitor that everything works? A lot less than in traditional solutions. Then we have the security orchestrator that seamlessly deals with instantiation, configuration, and management to compensate for the lack of IT expertise. It actually, facilitates this third question: how will I install this? How will I operate the system? Well, you don't have to. It's more or less automated way, and also responses are virtually instant. Even if we detect that the service failed, the attestation of a, let's say, duplicate of this service can be instant, because it's not necessarily human operated, but it can be automated. Then we have the threat intelligence, which is AI-driven detection of malicious activity and threat sharing to make the services automatically respond to most recent threats. Of course, we can design the system with a human in the loop as well, but the key element here actually is that since we offer these different solutions and not on-premises solutions, we can offer you limited GPU or CPU resources for AI that you don't need to have on your own, and you can still deploy the AI. So again, cost efficiency on the customer's end. And finally, we offer a remediation engine, which not only minimizes the response times, but also enables us to deliver services that are tailored to your requests. By your, I mean customers' request. So not necessarily the same threat will be handled the same way in each business. It can be completely personalized, as you will see in some of our demos. So why Palantir? Well, it is a cloud CPaaS deployment, a hybrid solution. Core services are on the cloud, and minimal additional integration into the customer's environment is necessary. low power, low cost, low complexity, easily replicated and deployed on premises, and services can be adjusted to the corresponding network conditions and resources. And finally, personalized responses. So it's not static, not only in terms of what we can detect, what we can remediate, but also how we do it. It can be completely personalized to the business owners to address specificity of each business. So this is the test bed that we deployed, this hybrid solution that we talked about. So we have a cloud space where most of the services are run also for the customer. We have Palantir Edge solution, which has Star, SEO, and Portal, and we have the Office. So as you see, on the only thing that we need to add to the client's environment are small Palantir clients that enable us to actually mitigate the physical devices or operate the physical devices. Of course, without a client, we cannot do it. The only thing that we can, without clients installing this client, we can only operate virtually the router. Other things, you need access to the physical machine, and this is a small program. It does not require a lot of resources, and it enables us to actually manage the machine and protect the machine as well at the same time. So now we'll go to the demo part. So the first demo will be detection and remediation of Lockbit as ransomware. And I will leave Valentino to actually explain the demo and comment the demo in more details. Please consider that since most of you have selected the hybrid option, the online option, we have prepared the demos as videos, not live demonstrations. And this is also because we cannot, we don't have a camera here to direct it into the machines. So Valentino, go ahead.
Thanks, Isidore. Okay, we'll present the three pilots to demos and one additional general risk assessment framework demo. So for the first one, we will present the ransomware detection and remediation of the Lockbit 3 as a motivation. The Cyber and CISA reports that last year the Lockbit was the most deployed ransomware variant across the world. So that was also one of the reasons we selected it. It's very easy and simple to get the virus because of the users can download it easy in the executable files, and it's hidden, so it's mostly so as the what the Palantir provides is that we track the victim and device logs activity to detect and mitigate infected and compromised entity. So now we will go to the scenario. So let's imagine that victim downloads the executable file. It doesn't know, and they execute it from the public server. And victim then access the malicious file. So the steps that we're going to present is the first, when the ransomware is executed, we have the Vazu agent, that is the Palantir client that is there mentioned. This is part that's observing the device activity, and it's exporting the logs using this Vazu agent. After we get these logs, they are sent to the TCAM, the Threat Classification and Alarm Management component that monitors and collects the logs and also puts the threat label to it. After that, it sends to the recommendation and remediation component, which reports the incident and also adds additional information collected from the TCAM, and also change the structure, prepares the structure to be sent to another component, which is incident response, that calls the action for the remediation, and that action is to shut down the device so that then the operator can remediate and investigate the deployed ransomware. So these are the steps. As you can see, we have the Sphera premise on the left, which represents the office part. And then we have the RAM testbed on the right side. The connection is made over the VPN. We have deployed the Wazoo client on one of the laptops, the end devices, where the user executes the log bit, which is then detected by the Wazoo client. And then the next step is that we notify the Wazoo server from that's connected. The client is connected to the Wazoo server, which then sends the logs to the TCAM, the threat classification and alert management, and which then prepares it for the recommendation remediation component, which then connects the contact the incident response to do the remediation of the shutdown. And the shutdown is done as the security capability from the security orchestrator. And after the shutdown is done, we can see we can check the portal. We will see that in the demo, where we will see the notification about the shutdown of the machine, and also the detection of the ransomware.
Yes, let me just complement here. Under Sphera parameters is actually we deployed this solution in a real environment at a micro enterprise from Maribor, which we were also, we subcontracted their activity from the project. So we are testing this solution also in the real environment with a bit more machines that are there, and sort of the edge solution part also offered here at our premises in Sphera. So it's really the same city. So it's really near or at the edge near to the client.
So let me just also say that this solution for the demo includes 7 components Palantir and the RAM testbed, which are communicating with each other to do the detection of manipulation. So now we will go to the first demo. So the user executes the ransomware.
Yeah, so in this part, we actually had to disable the Windows Defender.
Yeah.
That's the part of it, because you cannot really run the ransomware.
Otherwise, it detects it
It prevents it, yeah.
So now once the Wazoo agent detected the log bit, it sends the logs to the next component, the TCAM. The TCAMs then add the threat label and alarm the next component, recommendation remediation, which modifies the structure and sends the information to the incident response, which calls for the remediation to shut down the machine. And also we can see the notification on the portal side about the threat. The machine will now shut down. This is the automated steps, and also we can see the reported incident and the remediation done in the incident reports tab on the portal. Now this video was slowed down a little bit because the whole flow takes second, maybe, or maybe 2 seconds.
Yeah, so the responses are instant, but in order to display it and to explain a couple of things, we just slow down the video itself.
And that's it for the first one, basically. So now to the second demo. Here we made the detection and remediation for the SQL injection. Now, according to the Open Web Application Security Project, the injection attacks were the third most serious web application security risks 2 years ago. So the SQL injection allows the attacker to view and modify the database. In this demo, the plan was that the attacker tries to just to get to the data of the user.
Yeah, the important part why this demo was presented is because the micro enterprise actually deals with e-commerce. So they are actually, they have a lot of, we observed within their logs, their servers, we observed a lot of attacks that relate to tries to, do the MySQL injection to get parts of the database or even to delete the database. That was the main motivation why to deploy this as a service and demonstrate it as well.
So yeah, the scenario is next we have the attacker that's trying to inject the malicious SQL code into MySQL database and try to get the access of the user files. So what Palantir does in this demo, what the Palantir do is the detection and remediation by observing the device activity, also with the Wazoo agent, the deployed client on the end device. And again, we have similar flow, and that's doing the sent logs are then again labeled with the TCAM and sent to the RR, which reports the incident to the incident response component. And this time we have another remediation done, and this is the backup of the MySQL database, also as a security capability. And then we inform the portal about the detected threat and remediation. Also what we wanted here, but we were out of the time because of the dates, was to add the shutdown, but to allow the user to manually do the shutdown. We would send to the portal the recommendation to do the shutdown, but that's the outset of today's demo. So again, for the structure, we have the Sphera premise and run testbed. This time we have presented the Sphera premise as a cloud, where we have the MySQL database and also the backup server, where the backup will be stored. On the MySQL database side, we have deployed the Wazoo client, and attacker sends the get HTTP request with the SQL injection to receive the users from the table or the tables from the MySQL. The Wazoo client then detects that, sends the logs to the server. The TCAM takes the logs from the server, labels it, sends to the recommendation remediation, which then calls the incident response for the remediation to be done. The incident response then contacts the security orchestrator to do the backup of the MySQL database. Once the backup is done, we notify the portal about the done action, and we will show that in the demo. So also here we have 6 different components on the RAM testbed that provides this Palantir solution. So here we have the left top terminal, which is the attacker, representing the attacker trying to do the SQL injection. So now he executed his malicious code, which is then detected by the Wazoo agent, sent to the TCAM that labels it. TCAM sends it to RR that reports incident response, and then incident response call for the remediation to do the backup and notify portal. Now we can see the notifications. First one is from the TCAM that provides more details info about the attack that was run, and the second notification was that the backup was successfully done, as we can see on the backup server, and also to report that you can see the notification to the portal in the incident response tab.
And as you saw, you get a 404 not found response, so that actually the block was instant. It never came to the server, so the server didn't respond to the MySQL injection. So we actually protected it. That's the idea behind it. Because you have to consider that in a lot of cases, you can limit the access to the server, to the local host, but sometimes you need remote access, and then you have to open a port. Here we just use port 80 for the sake of the demo, but we can use it we can define any port to block, and we can also personalize their activity. We can shut down the server if necessary, but since you block the port, it's really not necessary to shut down the server. Another option would be if a company has, let's say, a replicated database that could start running that on the replicated server. So if you need, instant switch so that you don't lose the service itself, you can do it, because now when the port is blocked, no one can access and no page will be displayed actually on the web page, let's say. But if you have a replicated one, you can just run that one for the moment, just direct traffic there. But this is the only way actually to prevent MySQL attacks, because people will try. So this is the only way to do it, to have some alternatives as well. But as I said, in the remediation part, we can virtually do almost anything. Well, what is of course offered by the volunteer services, and we try to respond to the customer's requests as much as we can.
That's it for the demo 2. Okay,
Yeah, I'll just add this one. It's not only MySQL, non-SQL databases are very important nowadays. So that's why this demo 3, sorry to jump in, just to say why we wanted to show this use case, because this kind of attacks also happen on non-SQL databases such as MongoDB. Go ahead.
Okay, for the demo 3, we have added the medical database honeypot to the premise, which where we want to attract the attackers to collect the valuable information, and then to improve the security policies. So yeah, as we can see, the security. Okay, let's go to the scenario.
Sorry.
No, so in this scenario, the attacker will try to access the fake medical database. He doesn't know that it's the honeypot, but where we will collect the data for the future analysis. So the steps are the next. We are observing this device where we deploy the honeypot with Suricata, and then we export the Suricata logs. The Wazoo agent collects the Suricata logs and then forwards them to the TCAM that again labels the thread, but this time for the honeypot specific one attack. Again, we have the same components: recommendation remediation and incident response, which then makes the remediation. So here we can see the infrastructure topology. Again, we have Spera premise and run testbed. This time we have the HL7 FHIR medical database, and then the attacker tries to access or input the data to the HL7 in HL7 format to the database. This is detected by this Suricata, and Wazoo client then sends the collected logs to the server, where the TCAMs again labels the thread for the HTTP request. This time it was the post one that was trying to insert the data into the medical database. Again, the remediation is called, but this time we don't have the security orchestrator to do the remediation, but incident response just report the threat, the attack to the portal, where the users on the end can decide what to do about this found threat. So let's go to the demo. So on the left, we can see the postman, where we will send where we'll do the attack, trying to send this data to the database. Now we have this Ricotta dashboard where we can see that the detected the incident, the attack. The user then collects this thread which is connected to the specific port 2575 with HTTP post, and then sends the data to the TCAM. TCAM then sends to the RR, and RR sends it to the incident response that notifies the portal about the found threat connected to this medical honeypot. And it's the notification is again this attack is then again stored to the incident response tab. And it's up to the Palantir portal operator to decide what to do next.
But in principle, again, the process could be if someone's automated, you could block the port, you could shut down the machine, and all these things are always, backup is an option as well. Usually it will be done. We just, since we demonstrated backup before, we did not demonstrate it again. It's the only reason. Again, we can facilitate most of the wishes of our clients in this way because we can personalize the idea without any extra, let's say, additional really charges necessary to that one. And now we will actually demonstrate the final part, which is used when you first approach the customer. So we kind of tried to simulate the way how to objectively present to the customer what are the risks, and decide what kind of solutions we could offer to them. It's a rudimentary framework at the moment. It can be easily extended. It's machine learned, so it can also be automated and it can be always updated. And Valentino, go ahead.
So the rough, the risk assessment framework offers the questionnaire to the portal users, where they fill the questionnaire in two phases. The first one is to is a set of questions that identify the risks profile for the organization. I want to read the categories, you can read them. The second phase is to register the assets of the organization, and then to do the evaluation and find the maybe possible vulnerabilities connected to it. So go next. There we have this scenario for the rough demo. First, the user will fill the questionnaire on the portal. Once it answers it, it's press the submit button, which after that the user gets the RAF analysis. But in the back, what happens also is that the answers of the questionnaires are sent to the recommendation engine, which based on the decision tree then decides about the recommendation which will be done based on these answers. The recommendation engine contacts the service matching, which provides the possible security capabilities that can be deployed, the billing results and the costs of it. The results from the service matching are sent back to the recommendation engine, which then returns the recommendation with proposed security capabilities and other results to the portal. And this is then presented to the user in the specific tab. In this demo, you will see that service matching proposed the deployment of specific security capability, which then is offered to the user, and the user can manually deploy it.
Yeah, that's the outline of the workflow that we just explained. So we will not go into detail into this one, but as you see, the main components are portal, risk assessment framework, recommendation engine, and service matching components.
I will go to the demo. So the user on the portal side is going to fill the risk assessment framework questionnaire. And we speed up the process of this, filling the questionnaire. It fills the phases based on the assets and the company. So after the submission, he gets the analysis from the RAF. And what happens in the back is that we will see that next is that the questions are sent, the answers, the collected answers are sent to the recommendation engine, which then decides about the recommendation that is then asked, the specific one that is asked from the service matching. The service matching then answers back with specific security capability ID to be deployed, and that can be deployed by the user. And now user can access this in the proposed security capabilities in the dashboard, and we can see it deployed the user deployed the recommended security capability. In this case, it's IPNet flow.
And just a demonstration of the whole process being integrated.
And you can see it in the deployed tabs. That's the whole flow.
So that's pretty much the presentations that we have. We would like to thank you for your attention. Of course, there will be now time for some questions because we're well on schedule. But we would really like to ask you, especially those that are not from that are participating from outside Palantir Consortium, to actually fill in this questionnaire. It's very important for us for the future steps, you know, towards those directed, especially towards how to bring this solution to the market. Thank you very much. And if there are any questions, we are willing to answer them. Maybe me and Valentino cannot answer all of them, but we have a lot of also our partners from the consortium that can provide significantly more details as well. Thank you. So any questions? Comments? Everything is welcome. Okay, if not, thank you very much again. And thank you for your attention. And I think we're ready more or less to close the meeting. We'll stop recording as well.